Alright, Stardate Murphy's Log. Out here in the black hole in Murphy's Playland. Or goddamn romper room. This is the jungle in mathematics right here. It really is a tomb. If you know the combination, if you know the period, the decimal point, or a few x's in terms of the multiply and the dividing system inside of here. See, you look at it all the time, and you don't really understand it. Because one, it's super simple. And two, it's one of the most complicated things you will ever do in this entire... quantum physics is easier. Quantum physics has stuff to realize. But if you don't know that I need you to back it down and sit your sorry ass down, alright, then math's not going to be for you. And you're going to have a real hard time with trying to figure out brief meetings and sitting down in there Doomslayer and being that one interviewee by the SCP Foundation where they punch sharks and now you're over there from a director. Yeah. The crazy in terms of what the numbers are. Now, I want you to really kind of get that, because in mathematics, meaning equal but not equal to is an equal sign with a slash in it. It's pretty straightforward. And that means equal, or not equal, inequality. And then you get equals, equality. Why is that generally first when we were going to start with something of the square root of negative 1i inside of here about why we just drill that down your face, failure proof, until you understand, son. This is going to be a strict less than, and always in this position, the strict less than before you get to the strict greater than. And we describe that with a math equation. 10 is not equal to 6. Never has been, never will be. 10, however, is equal to 6 plus 4. Not 4 plus 6, 6 plus 4. 6, in that way, is less than. Strictly 6 less than 10. But 10 is greater than 6, right? And you don't understand. You can't have the 6th in the 10 position. 10 is always greater than 6, and 6 is always less than 10. Okay, and this is something as a math student, you may not understand a little language barrier, but I need you to back it the hell down while I'm explaining this brief in the Daily Flush, right? So you're going to get into it. And now you might get an occurrence where the less than or equal to is actually correct. Now, what are you talking about, England? What are you talking about with your E equals 2 point whatever? This number at the 50 decimals beyond the thing that only you can attain in this universe, and the nurses are still using 2.5 for centimeters against an inch. See, the language we speak is super critical, whether it's Roman, Hindi, Hebrew. Like, you're going to need some of these numbers because maybe when we're dealing with some of the language variables, see if I still got it up here, the language systems that we'll be getting into here later about one of these pages having, I'm going to have to steal some of this, but this alphabetical structure to it that'll give me a pin in. All right, so which one of these number sets do you work here? And I will draw you the field. And whether that's this racetrack or something else, you're going to be able to understand whether we're pretty good to it or not. Now, goats, apples, X's, once I get the numbers to them and we kind of all get what 7 is, or I can at least understand to you what 7 is in Hebrew or Hindi or Roman. Now, obviously, the numbers for the most part are going to work, and we're going to make that adjustment much like you do in the Putnam, right? MN only equals F when there's an MMA. This Engling angle to numbers will round off past decimals of what E represents when we start to break down what these later equations, when we get into some of this here material about what these are representing. Now, I want you to stay with me because that material up here is kind of a combination of this, but it's basically your real basic parts. I might have changed some numbers around to help you with the equation and give you the square root, the fraction inside of here. I'll give you the division in this, and I'll give you 3 over 5, right? Or 5 over 3? What do I give you here? I give you 2 over 3 is what I give you. And I also give you 1 over 2, right? Because they're very different numbers at the fractal inch and at the whole number where the 2/3 out of a thing. But what happens when we get 3 over 2, right? 2/3 is 0.666 under the 1. but 2/3 is 1.5. And this is something that you're going to have to understand too in terms of orientation and positions of this here ladder and how you practice it. Now, generally, with this concept that we all understood what x was, what the multiplication table is, but very specifically on this day of that phase, if we miss that number sometimes, then for sure we can go back to the way we were thinking, but we have a standard metrics that for sure in this orientation, mathematically fundamental to the institutional crazy people bring into this kind of thing, will it be relative? And you'll understand why it's relative, correct? Congratulations. You just got yourself a math degree. Just one, though. Just one. You can have more later. So we'll be going through this about this Euler's number, Engling's angle, is energy, right? And so I might change some things around inside of here. Maybe their orientation and position of what a derivative is, or which version of a derivative I would like to choose to say we are going to be using this. And when we speak into this language using mathematics, that's to the nth of y numbers on a field trip for PRIs and a rate index or derivative space over time, or money over time, being the nth derivative to the second derivative that we'll be breaking down into this, and why we use that specific fundamental. So that's my note. Again, we're going to get pretty compressed inside here. You might lose some paint, but that's okay. There are other ways to get this back, and when we find an example later that is worthy of one of these nth positions or the nth root of one of those subject matters, we will be able to adjust its position in here more appropriately. So figure out which way that does. Go round robins with groups or something, but do it for the Cubs, do it for the time bender over there, or any money, space, time, or any money, space, or matter variable that at the nth number makes a square root to the fractals equivalent or inequivalent to those standards. Catch you on the next one.